Excellent, great. Well, welcome everyone to this webinar for JMP Pro for researchers. This is a Q&A session here, so hopefully you had a chance to check out the recorded version of the webinar showing a bunch of JMP Pro features. And if you haven't, don't worry, I'm going to take you through sort of a brief tour of JMP and JMP Pro. But the main purpose of today is sort of to answer your questions and to hear what really you want to know about JMP Pro for your own research. And just to orient you, so my name is Julian Paris. I'm an academic ambassador with JMP, and I'm here today with Mia Stevens, also an academic ambassador for JMP. So we're both here to, always answer your questions about anything to do with JMP in general. But of course, today's main thrust is to tell you about JMP Pro, really the advanced analytics version of our main offering. And so let me give you a sense of what we're going to do today. I'm going to take you a little through just what JMP is in general. So even if you've never seen even standard JMP, I want you to sort of get an idea of what JMP is and what it does. I'm going to take you through a tour of really the pro-only features, really a subset of the pro-only features that we think are especially good for academic research. And then at the end, and actually right at the start, I want to point you to some resources where you can learn more and really ways to get started if you're already using JMP Pro or if you decide you want to use JMP Pro and want to get some help. And so I want to point you to a really special resource, the JMP Academic Community, right off the way. So jump.com/JAC or JMP Academic Community. And the reason I want to point you here is we've collected a number of different resources that we think are really great for getting started with JMP and for learning more once you've sort of had a first or second introduction. And so Mia actually just posted a really great resource here, resources for teaching predictive modeling. And so if you're teaching a course of predictive modeling or if you want to learn on your own, certainly check out this collection. There's also some new analytics case studies, so ways to learn on your own or ways to teach with JMP. And we have links to our recent academic webinars and lots of other materials right on our community page. Now, sort of a broader overview you can find at jump.com/academic. If you'd like details on just general resources for JMP, this is our academic landing page. And also if you have any questions about how to get JMP. And so at the end, I'll talk a little bit about getting JMP Pro and how to check if you already have JMP Pro. But if you click on the Get JMP link, you'll be taken over to a Get JMP page. You can get a trial. You can try out really all the features of JMP you want and see other ways to get a license. And also under Learn JMP, you can look at really a broad overview of the resources we have to get started. So some of these point you to, of course, the academic community, which I already showed you. But one we really love is the Learning Library. Really great way to get started. So I'll come back to that at the end and give you another sort of overview of resources. One other thing I want to point out is there's a great book actually authored by Mia Stevens, who's on the call with us today too, Building Better Models with JMP Pro. So if you'd like a semi-technical introduction, I mean, it goes through a lot of practical examples, but gives you a little bit of a sneak peek behind the scenes on how some of these predictive models actually work. And so if you're learning how to do predictive modeling and you're learning in JMP, this is a really excellent book. And so you'll also see data sets and examples linked from the academic community. All right, so let's actually jump into what JMP is in general, and then that'll take us towards what JMP Pro really is. And so I just want to give you sort of the basic background about why JMP even exists. And it's been around for about 26 years. And the reason it got started as a product of SAS is because one of the co-founders of SAS, John Saul, who's still the chief developer of JMP, back in 1989 decided he really liked how the Macintosh computer worked. It had a mouse, it was interactive, it was graphical, and it took the barriers away from using a computer environment. Before that, we're writing code, we're using a command line, and that stifled, in his mind, a lot of people's creativity and ability to use a computer. So he thought, well, why couldn't we make statistical analysis unleashed in the same way? Why couldn't we make it easy and interactive? And so that's what John developed was JMP 1. Here's what it looks like running on a Mac SE. This is actually still running back at SAS. And the idea was to make an interface to data, something that was very easy to use with a mouse, and you can click and you can interface directly with the data set. And so I'll just pull up in some quick examples here. These are some sample data, and I'll show you where these are in JMP in a minute. These are Hollywood movies, and so let me just show you some of the ways we can interact with this data set. Instead of just looking at the data in a table, I'll just go into a platform in JMP. I'll go to Graph Builder. And this is one of the main graphing platforms in JMP. And let's just drag some things around. If we want to make a visual, let's say, of how the audience score relates to the Rotten Tomatoes score, well, we could just drag columns around and we get really a nice little representation of the data. Here with a smoother, something we can change the sort of the stiffness of to find non-linearity if we think it might be there. And we could do more than this. We can actually break this relation apart. Let's look at this broken apart by genre. And here we go. I'll wrap the relationship so we can see for different genres of movies. Maybe there's one in which the audience score doesn't relate to the Rotten Tomatoes score. Or let's start over here and let's actually look at how maybe the Rotten Tomatoes score relates to genre in general. Let me get some box plots here. So I'll just click and drag these around. And so the great thing about Jump, and this is true in general with Jump, is there's no coding, there's no restrictions to how I'm doing this, or there's nothing getting in the way of me learning about my data. I can do it quickly and efficiently. And so the whole idea with Jump is to be that quick and to be that simple. And this goes from the basic things, from graphing, all the way up to, I can do, advanced analyses with the same point and click. So here, let me just get some multivariate output looking at a scatter plot matrix, or, we can get really fancy. I'll put on a 3D ellipsoid plot so we can look in 3 dimensions. All these things are driven from the mouse, and so it's very quick and efficient to get an idea of what's in your data set. And so that's just really a basic of Jump in general. Jump's meant to be quick, efficient, interactive, and powerful, and it's built for the Mac and the Windows right now. Jump actually stands for John's Macintosh program, and that's again because John Saul in 1989, wanted it for his Mac. But it's since become, Mac and PC software as well, co-released. We're on version 12 right now, and version 13 is coming out being built right now, actually ready to come out in the fall. So if Jump is this interactive, visual, powerful interface to data, well, what is Jump Pro? And my little pithy statement here is it's an enhanced version of Jump, including advanced modeling and analysis tools, making it, at least in my mind, the most sophisticated graphical interface to data that's ever been created. And I've been using Jump for about a decade now. My background was really, I used some programming environments, some SPSS. I'm actually an experimental psychologist, so I use Jump for research, and I really fell in love with it. It was the best way I've ever found to actually get to know my data. And I think you'll see as I go through some examples that Jump really unleashes you from the restrictions that a command line interface really places on you. I mean, I always mention this to people. If you get a data set, here's some basic demographics, and you just want to get an idea of what's in your data set, you don't want to have to write lines of code in order to get, let's say, histograms. I'm just going to do this quickly for you. I can very quickly create this output and get a sense of, what's in every one of my columns. If I see an outlier, maybe there's a data set or a data point here, population at, 40 or 35 million. I can very quickly go to my data set and say, oh, that's California. Everything in Jump is linked and interactive, so there's nothing restricting my ability to get to know my data set. So that's really what Jump's all about. Jump makes it quick to get through your data. So Jump Pro, being the advanced version of Jump, really adds a couple special features beyond native Jump, which allows you to do some really advanced models and advanced analyses. And they fall into several different sort of domains, I would say. And so let me take you through sort of the section of what I would call pro-only features. Now, in the previous webinar, I went into these in a lot more detail, but what I want to do right now is just go into a couple of just basic sort of overviews of what each of these are. And then what we'll do is we'll turn to your questions. But just in case you didn't see the previous webinar, let me take you through a couple of these. So bootstrapping is a general feature that's been sort of enabled across all of Jump Pro. And bootstrapping is really the situation where if you want to develop confidence intervals around a statistic, and perhaps the sampling distribution of the statistic isn't known. For instance, you want a confidence interval on the median, or your parametric assumptions aren't met. So you're sampling, let's say, from a distribution that's very skewed, and you don't trust that your confidence limits around that statistic actually meet the assumptions that you would have for a normal population. Well, bootstrapping gives you an ability to create sampling distributions really from your data set, to sample with replacement from your data to find out how that statistic changes from sample to sample. And so let me just go back to actually the data set I had in one of my examples here, my US demographics, because there was a column that was actually quite skewed. So population, you probably saw. And so let me just bring open that histogram again. I'm going to go to Analyze Distribution. So this is the basic distribution or one variable platform in Jump. I'll cast population into the Y role. I can drag it or click it into Y. And what I get is this basic histogram here, which I think popped open. Yep, there it is. And if you've never seen Jump before, I'll just orient you. So this histogram is oriented vertically. That's a pretty standard thing to do in Jump because our screens tend to be wider than they are tall. So it makes sense to have them across the panel there in the wide format. I'm going to go to a red triangle, which if you've never seen Jump before either, red triangles are little menus in Jump. And they're menus that react to the context you're in. And the context I'm in right now is sort of the one variable platform. And the top red triangle really applies to the whole platform. So I'm going to tell it to stack the platform output, which will rotate my histogram. So this may be more natural if you've never seen vertical histograms before. All right, so this is a very skewed distribution. So we may not trust that my upper and lower 95% interval here for the mean is really trustworthy. Maybe we don't think that that is really a reliable indication of that. So how might we bootstrap this statistic? So again, the sampling distribution unknown. Well, in JMP, this is enabled all across JMP as simply a right click. So I can right click any table in JMP and I can select bootstrap. And so let me show you what that looks like here. If I want to bootstrap this sample mean, I'm just going to right click this table and select bootstrap. And so bootstrapping, I'll just let it do 100 right now. If you're going to bootstrap a sample statistic, I would actually recommend in practice, maybe do 5 or 10,000 just to get a nice tight sort of estimation of that. Now what you're going to get, I want to orient you here. So the columns of this bootstrap table are the 100 samples that have been resampled with replacement, plus the first original sample. And the columns are actually the rows of the summary statistics table over here. And so if I was interested in the distribution of sample means that I got from bootstrapping, well, that's this column here, the mean column from the 100 samples plus the original first sample. And so if I look at 5.86, notice that's the original mean. And then every time I take a bootstrap sample, I got a slightly different mean. Well, in order to get an idea of what samples I got or what means of samples I got, I can again go back to the distribution platform. I'll click in this mean column just so that's what we're looking at. And then this time you can see we have really a representation of the sampling distribution of the mean. And what JMP will do when you bootstrap is give you confidence limits. And so now we can actually have our bootstrap confidence limit for that mean. Now, notice that this process could have been used for everything from a mean to a median. Maybe we want to bootstrap a regression line or bootstrap the regression slope or intercept. So whatever real statistic we want, bootstrapping is a general purpose sort of operation in JMP. So anywhere you want to do that, you can simply right click and bootstrap. So that's the JMP Pro only feature, and that really enables a lot of different types of research, especially when you're working with data where your normal assumptions aren't met. Now, really another general feature that's been enabled really across the software in JMP Pro is the idea of validation. And so validation is especially important for predictive models. And the idea being that it protects you from overfitting models, models that are greedy with how they use variables, or models that want to fit really in a sort of as well as they can to your existing data. So what validation is in general is this idea of holding out part of your data set such that you can fit your model to one piece, sort of your training portion of the data set, and then test the model's accuracy or prediction on parts of the data set it never had access to in order to fit the model. And so validation being, it's really a general role actually in JMP Pro. And so just to give you a hint about this, and so if I go to fit model, sort of a general modeling platform, if we're predicting something like, say, like household income from a number of these variables, I'll take a few of them, notice that there's a section in JMP Pro for validation, and this will accept a validation column. Now, the validation column can be made in several different ways. You can actually make one in your dataset, or maybe you already have one. One nice thing in JMP Pro is if you don't have one, you can just click this validation button, and JMP knows that no column is selected, and it lets you create one. So let me create a validation column, and I'll say that my training set, that is the portion of my data that I want to subject to sort of training the model, can be 0.7, and then the validation portion could be some other proportion, so 0.3 in this case. So I'll let that create it. And notice that what it did is created in my data set an actual validation and training portion. And so this is especially useful when you're working with things like stepwise. So stepwise procedures where it'll search through the different predictors and have some entry and exit rules for sort of terms that could be in a model. And the validation will really work, or the validation portion will be for the stepwise procedure. Then what's tested at the end is that training portion. And so I'll just do something quickly here and let it do a forward selection with the most maximum validation R squared. So maximizing the R squared for the validation subset. And notice that JMP will select some of these predictors, and I can just right here go ahead and run the model with the set of predictors that was selected from the stepwise procedure. And so validation is enabled really in general across JMP Pro. And so whether I do it through the Fit Model platform, whether I do it through some of our modeling platforms, so partition being one that's very commonly used. So as you're setting up your partition models, you can actually use your validation column here. And this is a general enablement. So in JMP, you can really make sure your models generalize well. And so in general, validation's very useful to use, and so certainly be aware of that. Mixed models in JMP Pro, again, useful in a wide variety of circumstances. I anticipate we might get some questions about this one. So when you have randomized block designs, split block designs, you have panel data models. So this is in the form of random effects. And so if you have individuals that are measured multiple times or across multiple things, often in psychology, so repeated measurements, so when within subject errors are correlated, so again, measuring the same people or same units repeatedly. Hierarchical models, so these are, HLMs or multi-level models, so students within schools, within teachers, for instance. And spatial variability, so when you're trying to model geospatial regressions. So these are all sort of subsets of mixed models. And one thing that's great about JMP Pro is you get a dedicated personality in the mixed model platform or in the fit model platform to work with these mixed models. And so in the video, I showed a couple examples. One that was, I think, pretty often used is this cholesterol data set. And so a situation where you have individuals, so patients, that have been measured repeatedly over different months. And so they have some observation here, their cholesterol, and some of them are different treatments, so treatments A, B, C, and some are placebos and controls, and they're measured over time, so different times, and we have different days here. And so one thing that's valuable about the mixed model platform in JMP Pro, if I switch over to here in the personality, so under mixed model, is the mixed model personality in JMP Pro allows for not only the specification of random effects, but also we can specify specific repeated structures. And so a couple that are especially useful, so an unstructured covariance matrix. So this is really when you're estimating every covariance in your mixed model. And so it's the most costly in terms of degrees of freedom. You have to estimate a large number of different covariances, but it doesn't impose anything on the data. And so one thing with mixed models and general repeated measures models is often this assumption of compound symmetry, so that the covariances are all the same or at least the same in particular ways. And with unstructured models, you don't have to make those assumptions. You're instead estimating all those covariances. There's also actually really parsimonious models that you can fit, so AR1 or autoregressive structures. And so in this data set, the example or the simple explanation would be fitting a model in which we're assuming that individuals' measurements, so patients' measurements here, for individual patients are correlated, but that closer in time measurements are more correlated. And this should make sense. So someone's cholesterol from sort of in April PM and April AM, so the same day in April, just day and morning, or morning and night rather, we expect that those will be highly correlated. Someone's cholesterol is not going to change that much within a day. But someone's measurements from April in the morning till June in the morning, well, those will have a lower correlation. And so an autoregressive structure says that the relationships between an individual's measurements, which is the idea of using a mixed model to account for within subject correlations, that relationship is scaled by the distance between the measurements. And so that's the idea of using something like days here as a repeated structure or repeated column, so that more distant measurements have less of the correlation than sort of local measurements. And so mixed models in general allow you to take into account these within subject correlations. And so the video I had before actually showed a number of these different models. And so the great thing about JMP Pro is a more flexible mixed model platform there. Now, another big sort of group of enhancements in JMP Pro are the data mining platforms. And so data mining in general, we could think of it in a number of different ways, but it could be searching for valuable columns in a data set, ones that are going to be useful for making predictions. It can also be sort of thought of as a process to find sort of structures in your data that you may not have necessary predictions about already. So if we take a data set, let's say like credit card churning, and so we have a lot of observations here, 4,000, of whether somebody who gets a credit card leaves the credit card company or not. Maybe we don't have any idea what about these individual customers can be predictive of whether somebody is going to leave a company or not. And we want to let the data sort of suggest to us the structure, suggest to us what things are valuable or important. And JMP Pro adds a number of additional data mining procedures that really enable you to find these complicated relationships. And so, for instance, in the neural network platform, and so neural networks in JMP can now do multi-layer. So if we're, let's say, looking for whether somebody churns on the basis of a bunch of predictors, so neural always requires a validation column. In JMP Pro, you can actually specify your own if you like, or let me actually just deselect my columns here. We can again use the trick. We just click the validation button and JMP will let me create a validation column. One thing that's valuable about the JMP Pro neural networks is the multi-layers. And so we have more link functions and we can have second layers to this. And so if we want to create even more complicated models or neural models, we can do it. Neurals are fairly black boxy. That is, they are going to create a very flexible structure, but sometimes that's a very useful thing to do. You may not use your neurals uh, necessarily for the prediction, but you may use them to identify useful variables. And so neural is a very useful tool for that. Now also in JMP Pro, under our partition platform, and so modeling partition, and so these are recursive partition or classification trees. If we go to this partition platform, you notice there's a couple additional options. So not just decision trees, but bootstrap forests and boosted trees and k-nearest neighbors. And so additional sort of modeling or partitioning techniques that have certain additional properties that are very useful. And bootstrap forest being an especially nice one, taking subsamples of not only rows, but columns as a way to find really the most predictive sets of variables in your data set. And so this is a very nice one, especially the bootstrap forest. For instance, let's predict our churn on the basis of our predictors. We have a validation column since we have JMP Pro here. And one thing that's very nice about the bootstrap forest is something called column contributions. So once we actually fit this predictive model, we can ask JMP to tell us which columns have really contributed to the prediction of churning. Remember, churning is whether somebody leaves a company or not. And so via the sort of way this model works, it's able to pick out a lot of columns that tend to be involved in that prediction. And since Bootstrap Forest takes subsamples of columns and rows both, it's able to do it in a way where a predictor that tends to be very, very influential or very predictive doesn't trump, or I should say doesn't mask the value of other predictors. And so the column contributions is a really valuable tool within JMP Pro. Maybe we want to use these to inform then a more parsimonious or simple model. Maybe we want to take ourselves over to a general fit model platform and actually fit this as maybe a logistic regression, using the columns that we think are now most involved. And so even if you're not going to be using data mining sort of the end of your analysis, you can use it at the start of your analysis to inform sort of choices about what you're using in your data sets. So data mining in JMP Pro gets very advanced, and that's a real sort of large platform in which we've built out in JMP Pro. Now, when you build up a number of models, and this happens often, the model comparison sort of utility is quite useful. And the value of model comparison here is that once you've created a number of these different models, you're actually able to then compare them, compare their predictability. And so I think I have a data set here where we have a number of different models that have been built for prediction. Here's a good example. So again, marketing data here, but we have a couple of different models, a stepwise model predicting churning, a boosted tree, a neural network. If we want to compare how these models make predictions on JMP Pro, under that modeling section, we can actually go to model comparison. But just to finish off our quick overview, because I realize I'm going short on time, even though I thought I was going to do 20 minutes, I'll just point out a couple of these. Partial least squares being a really valuable tool when you have specific data problems, so situations where what you have are sometimes more columns than you even have observations. And so an example of this that I gave in the previous demo was a situation when we were looking at contaminants in the Baltic Sea. And what we have are spectra data, so spectra measured for, it looks like 27 different equally spaced spectra intensities. And we only have 16 observations, and we're trying to figure out which presence of which contaminants there are in the Baltic Sea. So making predictions about, on the basis of the spectra, what's present in the water. And so this is a very difficult situation for most models. We actually have too many predictors relative to the number of observations we have. And the value of partial least squares, and I'll get to this from fit model, the values of this special partial least squares sort of implementation is that it's able to take these intensities, and I can have them all as model effects, And what it's going to do is in essence, reduce the dimensionality on the predictor space so that we can predict these contaminants, these different, one's a detergent, one's a natural contaminant, one's sort of a byproduct. We can predict these contaminants on the basis of a model that's really reduced the dimensionality on the right-hand side of the equation. And so I went through a lot of more details in the original webcast, but what this does for us, if I scroll down here, is it's going to reduce the variance in the X space. And so with just one single predictor almost, or even just two factors, we can explain almost all of the information that's on the predictor side of the equation. And the reason for that is that these intensities are highly correlated with each other. If I go to multivariate and look at these intensities just in a scatter plot, what you'll see is that the correlations are, up in 0.9, 0.8, 0.9 for most of these. One nice way of looking at these is under the red triangle. I'll just do a color map on the correlations. And so what we're looking at is how highly correlated each variable is with each other. And you're seeing a big block of blue because each variable is almost perfectly correlated with every other variable. And so when we actually do something as partial least squares, what it does is reduces the dimensionality of that right-hand side of the equation. So instead of having 27 factors, we're actually using just two to make predictions. And it does very well for predicting the contaminants. And so partial least squares is a nice sort of specialized model for solving that problem. And then finally, generalized regression, so a different way to use sort of modern modeling techniques. And so it captures really a large number of circumstances, non-normal responses, situations where we want to model quantiles or screen predictors, or situations when we have high multicollinearity. And so generalized regression, again, is a sort of a special personality under the fit model platform. And let me open up a data set. I'll do credit card churning again. And so our personality here, if we set to generalized regression, it allows us to do a number of different things. So if I put churn flag as my Y, you'll notice that we can have a number of different distributions here that we can actually model with. And so if we're doing ones and zeros, binomial is a nice fit for this. Notice we can do zero inflated versions, and so we have a lot of options, or we can model quantiles if we're working with numeric outcomes. And again, we can allow the model to have sort of a lot of flexibility. If I put a number of model effects in our data set here and hit run, this will jump a second to load here. We can choose the types of estimation methods. These are penalized estimation methods, so putting penalties on the actual terms in the model. And so we have a number of options. I went through more of these in the previous example that we did with the webinar. I'll just hit go here so we get an output to look at. But the purpose of generalized regression being that we can actually use our predictors and allow the model to select which ones to actually utilize in the model itself. And so it can zero out predictors that are not useful, so remove them from the actual model. And what it can do for us is once we've allowed it to fit, notice that some of these predictors get zeroed out, ones that aren't valuable in the model. And so instead of using stepwise procedures to pick terms in the model, we can do this in a more sort of modern way. And this is an interactive modeling platform as well, so we can actually step backwards in sort of the magnitude estimate, so how much we're really allowing to go into the model and see the response really for our measures of model fit, so the Aki-Aki information criterion here. And so generalized regression being a nice generalized modeling platform that allows you to work with many different types of link functions and also allows you to fit your standard model. So if you just want to do standard least squares, you can do that as well in this sort of generalized platform. All right, so that's just a brief tour of really what I talked to you about in the previous webinar and the pro-only features for JMP. You probably get the sense that JMP Pro has a lot of stuff in addition to JMP as well. And if you've never seen JMP to begin with, there's a lot in there that I haven't even shown. But what I want to do with the remainder of this webinar, and hopefully Mia can tell me if you've had some questions, is basically I want to tell you about really whatever your questions are, or help you through whatever situations you're working with the data to see if JMP Pro is really the right tool for you. So I'll pause here and just see if Mia has any questions queued up. Mm-hmm. Mm-hmm. Absolutely. Yeah, so let me bring up a data set here and let me see. I think I have none in my data set here yet. So let's say we want to create a validation column. We have actually a number of utilities, and if you go to the columns menu, we haven't even looked at this one yet, but there's a number of things we can do here. So under the, oops, let me click over. So under modeling utilities, notice we have a section here called Make Validation Column. And so this is just like when you're in a platform and you're clicking that Make Validation, but the value of this extra little section is you can do a number of different things. So sometimes when we're making validation columns, especially with smaller data sets, we may want to stratify or balance our validation across something in particular. And so this data set's pretty big, 245,000 observations, which means if I have something like gender in my data set or marital status or occupation group, my purely random validation will probably spread pretty evenly over those individuals. But take a smaller example. Let's say I have something where I only have 40 observations, so I'll open big class. So here's a data set that's relatively small. And if I want to form a validation column and I only have, let's just find out how many, 18 females and 22 males, maybe I don't want to trust randomness to make sure that my validation is spread evenly. And so if I go to columns, modeling utilities, and make validation column, so let's actually do this for the small data set. I'll tell it to stratify the split. So 3/4 over validation, 1/4, sorry, 3/4 for training, 1/4 for validation. And let me tell it to stratify across sex there. And notice that when sex was selected, now it's made sure that the validation is pretty equally spread over those two. And so if I can check here, let's make sure. So sex and validation, we get as evenly as it can to make sure that the splits is over that. And so very useful that, yeah, when you're designing your sort of validation beforehand, the columns menu, utilities, make validation column is a really nice way to do that. Yeah, great question. That's a great question. Yes, let me pull up a data set here that's got a lot of dimensions here. So we'll do maybe body fat. And so we have a data set where we have a lot of measurements on individuals. And individuals tend to have, people who are bigger tend to have bigger everything. So these are measurements that are probably highly correlated. And so let's just actually start with sort of the basic sort of elaboration of the distribution platform. Remember, distribution is univariate. And so just again to review, if I look at all these in a univariate way, what we're really saying is, what's the distribution of each variable? If we want to look at how they all interrelate to each other, the sort of extension of that is under the multivariate methods subsection, and it's called multivariate. And I love to start with multivariate for this question because what we can do is take all of our columns, let's put them into Y, and I'll hit OK. And we start off with that correlation matrix you saw before and the scatter plot matrix. And so let's just look at the scatter plot matrix here for a second. You notice that there are fairly high correlations between most of these, and so they're not perfect. Some of these are wider, where we're looking at our density ellipses, and the degree to which the major axis is longer than the minor axis is the correlation. So if they're really oblong versus being a circle, that means we have high correlations. And so maybe we want to reduce the dimensionality of this data. We don't want to use the number of columns we have here selected, so 26 of them, or actually it'd be fewer than that, maybe 20, yeah, 14 of these in a prediction. We want to maybe pull out some principal components. There's a couple options we have. And so if I go to the multivariate methods subsection, I'm going to show you a couple different things that I would recommend. So first is going to principal components. And principal component analysis is really a general way for reducing dimensionality. So I'll click those into Y. Under estimation methods, we're going to leave it as a default right now. But in a minute, I'm going to come back and show you something very special in JMP Pro, this wide option. But let's look at the default here for a second with this small data set. And what principal components does is takes the really the principal dimensions or the linear combinations of these variables that explain total variance. So there's some total amount of information in these columns I have selected, and the sort of the thrust or the desire of principal components is to explain that variation with components or linear combinations of these variables. And so what this is showing for us here is our first component. So the where this point is, and a point here is a row in the data set. So where these points are on the x-axis is their amount of component one. And on the y-axis is amount of component 2. And the percentages listed here is really the amount of variation that that component explains. So let me show you how we might use this. We can visualize where an individual is on component 1 or 2, or how much a variable loads or relates to. That is, in the weighted average of the columns, how much it really loads on a component. Or, under the red triangle, remember those are little menus, we can save principal components. So let me select this option. JMP's going to select, sort of as a default, the number of components that have an eigenvalue above sort of a threshold, or above, really quite above 1. I'll let it save 2. And I want you to see what it did is in our data set now, we have 2 new columns, principal 1 and principal 2. And if I right click on one of these, notice that it has a little formula with a checkbox next to it, or a check. And that means that the way it's calculating these principal components is with a formula. And it turns out the formula is not that complicated. It may look complicated, it's just a bunch of numbers here. But look what it's doing. It's just some amount times each column. It's a weighted sum of all the different columns. So a component is really just a weighted sum or a weighted average of all the columns in the data set. And so each component weights the columns differently. And by doing so, we get a value that sort of explains the observations in those different columns. And so we could actually use these principal components in a modeling sense. We can use them to predict something else, or maybe those are the things we want to predict. So we can reduce dimensionality on really either side of the equation. Now, the problem with principal components is what do they really mean? So, they're loading on a certain variable. And so if you actually pull open loading plots or loading matrix, I'm going to do the formatted loading matrix. What you'll see is, and let's just look at the first two here, that the first two components, and remember these are the weighted averages I use, these are sort of standardized weights. And what we're seeing is that, well, weight itself of a person loads really heavily on the first component, then hip circumference. All these are kind of like general size, like how big a person is, right? And the second component has things like age, height. It's negatively related to ankle circumference, interestingly, and then positively with abdomen. So this is sort of the age variable mostly. It's principle 2. So how old somebody is and how generally big somebody is are the dimensions that really explain our data. But notice that I'm having to come up with explanations for what these things are. So that's a little bit of subjectivity. So a thing I love about JMP Pro, under that red triangle, there's the option to cluster variables. And cluster variables just literally means takes the variables and finds representatives of sort of the groups that individuals are clustered on. And so if you look right now, we have 2 clusters in our data set, 2 clusters on the variable side. And the most representative variable of that first cluster is really weight, an individual, how heavy they are. And it's explaining almost 70% of the variation in that cluster, or 60% of the total variation in the data. And the second cluster, that second component really has the most representative being age, how old somebody is. And that's explaining almost 60% of the variation within that cluster and about almost 10 in the total. And so if I wanted to just use these 2 variables, rather than extracting components of variation, I want to use the most representative components of the variation that's existent in the data set. I can even select them here. Under that red triangle, I can launch fit model directly. And so from here, I can pick those 2 representative components. It sort of added them to my model effects section. Maybe that's what I want to predict body fat from, just weight and age. And so by predicting them with sort of manifest variables, not variables that are sort of derived from other variables, it makes the interpretation a little easier. So now if I go to my favorite is under factor profiling, the profiler here, and if I want to look at how these variables relate to percent body fat, now I'm using variables where I can, actually choose the levels. Somebody who's, 34, who weighs 100 and, let's say 90 pounds, the prediction for body fat is 18.93%. Right, so instead of having to use, how much does somebody have on principal component 1 and 2, I'm using real variables, and that's a nice way to do it. Now, so that's one thing in JMP Pro that's special, that cluster variables, which is a very nice way to pull out those representative groups. Let me show you another thing in JMP Pro that's quite handy. Which comes up actually for, I assume, many of you who are doing maybe research with maybe genomic data or any data where you have very, very wide data sets. And so this is a data set of only 230 people. And it looks like we don't have too many columns, but that's because there's one group of columns here that's been sort of minimized, which is 10,787 columns. So what we're looking at is actually breast cancer status. So this is the ER status here, present or not present. And we want to know if we can predict that on the basis of these different actual receptor statuses. So we have, what is it, 10,787 different sort of locations, and we want to know if we can predict breast cancer on the basis of these. And so this is actually a very difficult principal component situation. So if I go back to multivariate methods, principal components, and if I wanted to, I can cast the responses into my Y role. Um, I'm not going to click OK because this will take it a couple weeks to run. So if I try to invert a matrix here, that's what principal components will eventually do. That's 10,787 square. It's going to be very difficult computationally. It's a very difficult problem. And so under estimation method, there's a very special selection that's in JMP Pro for when what you're trying to do is find principal components from these really wide data, but without decomposing it in the standard method. And so this is a very special method called singular value decomposition that uses pseudo inverses. And this estimation, so let me hit OK. So instead of taking my computer a couple weeks to run, we'll actually be able to do this one live. And so it's taking these 10,787 columns, and the question is again, can we pull out some linear combination of these? And I'll open the eigenvalue section. And so it's found a lot of components. We had a lot of different variables. So 223 that sort of meet the threshold here to be useful. But now from 10,787, we can pull out 223 that we maybe want to use. And if we look at these, the percent of variance for each of these, the first component right here pulls out 56.57% of variation. So some linear combination of these 10,787, we can do just one and almost use half or gather half of the information. And so I may just pull out the top maybe 4 or 5 here. Once we get down to predicting less than 2% of variation each, maybe that's not valuable. Let's actually try that. I'm just going to pull out 4 components. I'll save principal components. I'll do 4. And so now from all these different variables, we can just use 4 of them to predict receptor status. And so that's actually a really valuable thing. Now there's another sort of platform in JMP that does the same thing, sort of this principal component idea, but does it as an implementation for prediction. And so that's actually under a platform we haven't seen yet. It's called discriminant analysis. Now discriminant's a very old sort of classification technique Ronald Fisher was very proud of. And discriminant historically has had the problem, just like principal component analysis, that you're limited by the number of different variables you can enter in on sort of the prediction side. And so if I wanted to use 10,787 as my covariates, this would be a very challenging problem for a computer. Computers can't do it even now, it's not fast enough. But now with this special wide option, so what JMP does with that singular value decomposition and these pseudo inverses, the wide linear option can actually do this problem. And actually it can make this prediction very quickly. So I'll take ER status here and let me put it on my X as my prediction, what I'm trying to predict. And what we're attempting to do here is basically to tell JMP, hey, use all these columns, take combinations of them, and find a way to predict the receptor status, and decide for each person or each people in the data set, whether we think they would get or not get breast cancer. And so it actually finds them in canonical space here. And it says that, given the observations we have, it's only misclassifying 8.69% of the time. And so it's actually doing a pretty good job. Now remember, with JMP Pro, there's a couple JMP Pro things we can do in tandem here. Let me go back to discriminant. I can recall what I had before. Notice I have an option for a validation column. I can again, let me select and sort of make sure nothing's selected. I'll click validation. It says no column is there. Let's make a validation. And now I could actually let JMP Pro do this, not just with this wide linear, so where we have many columns and it's doing that singular value decomposition. I can actually get, in addition to my regular misclassification, I can do it for the training and validation. So I can build a model with the training, and then on data that it's never seen before, it still is only getting 10% misclassified. So this is sort of the most honest representation of how well this model can predict. And so it's misclassifying at a very low rate. And notice we get a training and a validation section here for discriminant. Yeah, so there's a lot of dimension reduction techniques there. And we didn't even look at factor analysis. That's sort of a further implementation of principal components. Thanks. Mhm. Yeah, that's a great question. So I didn't even show the sample data, so I'm glad somebody asked this. So if I go to the help menu and go to sample data, this is where I found many of the sample data sets that I've been showing here. And if I scroll down, notice they're organized in a couple ways by type of data on the right-hand side, and also by type of analysis. And so mixed models, there's a couple ones that are listed here. And so one that I showed actually in the previous webinar for this one was wheat. And so this is actually nice for, especially when you're first introducing mixed models. I like to show this one because it's a nice general example. You have different varieties of wheat, and you're looking at how moisture affects yield. And the idea being that varieties, the different measurements for these different varieties, even though they're at different moistures, well, they're going to be correlated because if it's the same type of wheat, then sort of the yield, maybe we'll have, baseline differences in how varieties affect yield. And so this is a great example when you're first introducing people to mixed models. If you go to Graph Builder and you say, well, there's some general relationship between yield and moisture. So let's drag those both in. Here's the general relationship. Do we think that relationship is the same and starts off at the same sort of intercept for the different varieties? So let's just take variety and I'll wrap it. And notice what we can see is, well, if I hit done, you can sort of see it a little bit better. Well, they're all sort of the same slope, but they kind of seem like they're starting off at different places. They may have a different intercept. And so it's a nice way of showing, well, there are relationships that maybe we want to take into account with a mixed model. And so wheat is a very basic example. Cholesterol was one I showed you as well. And so that was the one where we have different patients measured across different days. And there's a couple other ones here. So tire tread and uniformity in animals. Each of these sort of come with a little bit of detail. So if you click on the notes, you can sort of see what they're doing. And most often they come with a little script here too. So you can actually run the model that's included. And so those are some nice examples for mixed models. Anytime you have repeated measurements, those are typically in that sort of class of model. So if you don't find anything you're looking for in JMP, you can also try Googling, repeated measures or split plot, and you typically will find some examples that may fit into whatever type of sort of situation you're using. Yeah, absolutely. Yeah. hmm hmm Yeah, absolutely. So certain times this will automatically pop up because that's how the script was written. But if it only pops up the actual analysis output, so the output window, the top right triangle will have this section for model dialog. And so pull that back up. And the nice thing there is you can see what fixed effects were specified, what random effects were specified, or what repeated structure was specified. And one thing I'll say about mixed models is if you're using the repeated structure section, you won't be using the random effects section. So if you're actually telling it to be an unstructured matrix, you're telling it to do something that sort of supersedes this section over here. But yeah, so for any kind of a script, especially when it launches fit model, know that you can always recover the model dialog by going to that top red triangle. That's great. Great point, Mia. Oh yeah, it's a great question. Great question. So if I go to fit model, there are options, and you may have seen this. So if I'm predicting, let's say, Y scores here, this is cholesterol, and I have sort of a structure of effects, I can actually define a mixed model using standard jump. And this is, I'm sure many of you have used before. So if I have, treatment and let's say month, I think time is actually my variable where I have them combined. Let's see, time. Yep. And so if I have these as, let's say, a full factorial or something like this, and patient is my random effect. So patient is the thing that I have repeated observations over. Now, in regular jump, under the attribute section, there's the ability to specify this as a random effect. And so I can designate patient as something that is random, and jump knows to switch this as a different estimation method. It's now doing it through residualized or restricted maximum likelihood. And so it's going to estimate instead of a offset for a patient, the variance across all patients. And so that's just how the mixed model works. So you can generate a mixed model using regular jump. The value of Jump Pro is when you actually get this specified personality here. So you can take it over to a special, really, platform within a platform. And the addition, notice is we still have our fixed effects and our random effects specified. It's this repeated structure section. And so when you're working with mixed models, the most basic assumption, if you don't have this section for repeated structure, is that you have essentially the elaboration of homogeneity of variance. So that what you're saying is the variance of the differences between levels in your random effect. That is the relationship between, let's say April AM and PM and April and May AM and PM. You're saying that all those differences have the same sort of variance, or that they're on average as different. Now, this is a great example to show that you don't expect somebody's score at April AM. You probably expect that to be pretty different than June PM, but you don't expect it to be too different within the same day. And so this is a good example of where you sort of know on the first principles here of how cholesterol works that you're violating that assumption that these scores are not just as different within patient one. They're actually getting less and less the same as you move further and further away in time. And so the effect of specifying a model with the residual structure with the assumption in place that they're all the same on average differences, you end up getting sort of biased results. And so this is where you actually get the value of Jump Pro. You can tell it literally using an autoregressive structure that we're repeating over different times and over different subjects, and that we actually want you to take into account the distance between these days. Actually, I would do it this way with the days here as numeric. So we tell it literally, scale how related you think the observations are by something quantitative. And if you have a situation where you don't want to impose any structure, you don't want to make any assumptions, sort of like removing the homogeneity of variance assumption from an ANOVA, you can tell it to use an unstructured covariance structure. And what that means is that it doesn't assume anything about how related things are. It simply will estimate. It burns, a little bit of degrees of freedom. It's more costly, but that's an option here in JMP. And so for more advanced mixed models, it's really necessary, I think, to have this personality, the mixed model platform. It's also necessary when you're working with certain types of multi-level models. So we didn't show any of these, but there are situations where you're nesting random coefficients. So situations where you have, students within teachers within colleges, and you're sort of nesting a coefficient. You want to fit slopes in a hierarchical way. And so that's a special sort of feature of the mixed models in JMP Pro. And so basically, if you work with mixed models a lot, you'll get a lot of value out of the additional options. Sure. Mhm. Absolutely. No, that's a great question. So let me go back over to our website. And the best place I would go is actually, let me just search Jump Pro on Google because it'll take you right there. And so it's this first one, Jump Pro. And you have a couple options. The new in Jump Pro 12 is nice if you've already been using Jump Pro. So you can see the special new editions. But I would go to the top landing page here. And actually, this is a great point for me to just sort of review these things with you. And so the ones I showed you are some of the predictive modeling and cross-validation tools, some of the modern modeling. So we looked at sort of how JMP can do some of these neural networks. We can do some of the generalized regression. We looked at mixed models, but there's some additional things I didn't get to in this one, although I showed them in the last webinar. So uplift models and some of them advanced multivariate. And there's a number of additional things. So covering arrays, a really advanced DOE when you're looking at deterministic systems, and the reliability block diagram when you're looking at sort of reliability in these discrete events. And so this is a great place to go, and sort of each of these has a section. It'll take you through what really the value of JMP Pro is for each of these, and many of them have screen clips and some additional links that you can go to. Yeah, so JMP Pro, and if you just go to the main website too, you'll be able to find that under the main drop down here. So once we get to the website, and we can go down to JMP Pro. Yeah. Mhm. That's a great question. So you can always reach out to us, and either me or Mia directly, or academic at jump.com, and we can find out if your school has the license that comes with the basically it's what we call the academic suite license. So you get everything, including JMP Pro, unlimited use. You can always find it if you search your college's software depository or repository. So a very easy way is just going to wherever you would download, Microsoft Office from your school, or anything like that. and you should be able to see a section for jump if you have jump. So that's also an easy way to find it. Yeah, great question. And if you're looking to get the single user copy of Jump Pro, this is actually another reason to go to jump.com/academic. And so if you are interested, let's say you have a research grant and you want to get your own copy that you can keep on your own machines and sort of manage independently of the university, if you go to the Get Jump section, you'll actually see that under individual licenses, there's the option for the single user Jump Pro. And so this is especially good when you're working with academic research and you have your own grant and you want to have one that's specifically for you that has nothing to do with the campus licensing. So certainly check to see if your campus has a license, but you can also get this new single user copy of Jump Pro. And so we're always willing to help you out, answer questions about that. And so certainly reach out whenever you have questions to us. Great, thanks, Chuck. Yeah, I'll just mention the learning more again. I said I would come back to that at the end. Definitely check out our Jump Academic community. Mia and I both put a lot of stuff on there. And again, if you're getting into predictive analytics, absolutely look at the new collection that she just put up there, the resources for teaching predictive modeling and the analytics case studies. And actually, these analytics case studies, they work just with this new book, so Building Better Models. And so certainly look into that if you're getting into just getting into predictive modeling and want like a really nice resource that covers sort of the basics and gets you into some of the details too. So that's jump.com/jump academic community. So JAC. Yeah, absolutely. Yeah. So in Jump itself, under the help menu, if you go under the books section, you'll see there's a lot of different sort of books that are all included with Jump. So the documentation is really well written. We have excellent writers. And if you go into the specialized modeling, so that's a great place to go for looking at the predictive models. And I'll actually just pull this up so you can see, 246 pages here, and takes you through a lot of detail. So if I go to the sections for, let's say we're looking at a partition model, I'll just go to the overview, and Jump tells you not only exactly what it's doing, and you can get really into depth if you want, go to statistical details, and it'll take you into exactly what's happening. I usually skip those myself, and I go into sort of just the details of sort of examples, how to do it. And again, Jump will always reference sample data sets. So if you're wanting to try these out on your own, certainly go through the documentation and actually try it. There's nothing like trying it yourself to really get into the learning of the software. So again, in the software, under the help menu, books, and pick out whatever section you want. Mhm. Wonderful. Well, thank you so much, everyone, for joining us. And there's a recording that I made of this, and it's going to be available under the collection for recent academic webinar recordings. So you can find it there, and I'll have Chuck and Pawnee send that out too as a link. So if there's anything I showed today and you want to see it again, certainly feel free to watch the recording. And yeah, we thank you again for joining us, and make sure to check out our upcoming webinars. There's actually one tomorrow on data preparation and graphics. So if you are a Jump user and you want to learn a little more about that, hope you can join us.